Hello everyone. So here we have a Dell Inspiron 7000 model according to the sticker, and they tell me it has no image. So do we have a power button? Is that a power button? I don't know. Is it charged? Probably should plug it in. Don't see any lights coming on. Maybe it's a no power. Let me see if I got the charger. Pop in the charger. Do we have light on the side? No. We have no light beside the charge plug. I can see a light, it's not lighting up. Do we have... Oh, look. There's supposed to be... There's actually a little window here for a light on the charger, which we have nothing. No light on the charger. There, I crank up the exposure. You see the little light, but it's not lighting up. Does it light up if it's not plugged into the laptop? I wonder. Let's unplug it for a few seconds from the mains, because if it's gone into a shutdown state, it might not recover automatically. So we'll just give that a few seconds. I'll plug it in again and we'll see if it lights up. Ah, green light. Now watch, I bet you if I plug it into the laptop it will shut off. Yes, cool. I reckon we have a no power rather than a no image, and there's a short on the board that's loading down our charger. So let's crack it open and let's reset that exposure. That's better. Oh, well that one seems captive, unless that was a mistake. Sort of pushing the lid off there. That one is also captive. I wonder why they only make some of them captive. And then those ones come out. Maybe it's to encourage you to know to open it from that end, perhaps. It forces it up. Can we... Bit of a pop. There we go. Okay, so someone's definitely been here before. So there's our PCB cover that has been removed at some point. The battery's been unplugged already. So fan spins freely. Let's take this all off and see where we go. Alright, let's take some measurements and see if we can spot a short anywhere. Multimeter in an obnoxious beep mode. Looking for shorts. We touch any ground point, which is 99% any exposed copper around the screw holes, for example. If you're unsure, you can go straight to the negative of the battery. So let's try, is that metal tag going to be ground? Yep. Same as the metal, on your ports, USB ports and so forth. So we know that's a ground. And let's start poking at inductors. So there's one down here by the SSD. No, 32 ohms. There's one here. That's nice and high. There's one here, which is really high, higher than 100. So I think my meter reads about 150-ish before it stops beeping. There's another one here. It's all good. What about here? Here. Nothing there. That's capacitors off the end of those. No, it's not. Ah. Okay, 2.4 ohms on the capacitors, and that's ground. That seems awfully low. What about this capacitor? That's alright. It's on that inductor there. Yep. This inductor. No. No. Well, that's good, because those CPU lines, we don't want them to be shorted. That inductor there, no. Okay, so we know we have a short on these caps. Well, it could be graphics, who knows? Maybe we, or anything, could be anything. I think we have to get the board out now, maybe check the other side and have a close look at what's going on around here. This being a short here is likely our 19 volt main line, and then that's getting switched through here to create a rail of some sort. See, there we go. There's another big capacitor that's going to be on our main line as well. Some of these MOSFETs are probably going to be, yeah, on the main line. So, oh, that one switched to ground. That one's probably switching to 19. So we have a short on our main input, and the charge socket is over here on the top right. So we need to have a look around here. Is that a cap? Let's go across our input socket. So that could be ground, but we won't get anything up here. So maybe it's after the input MOSFETs. So that's okay, that capacitor. And we've got, this must be a current sense resistor, I think. Okay, and this is our main rail. Nope, that's okay. Let's get the board out and have a closer look. It's not budging, so I have a feeling that the CPU screws might be holding the board down as well. So we'll just remove that. Can I take this off carefully? Just take that off as well. I think the posts that the motherboard sit over are holding that. It's holding that down. Can I? Oh, now it's free. Either that or I just wasn't lifting hard enough before. I don't know, now it's coming with it. We'll find out once it comes out. But you want to loosen off as much as you can. You don't want to start pulling at stuff and hoping. That's how things break. I think there's a screw holding that. Charger socket. There we go. Okay, I'm going to have to take the battery out. There's a flex under here that's not going to come off easily. Doesn't it seem weird that they have this tiny little silver screw in the middle battery support, yet the rest of the motherboard is held down by these slightly larger black screws? So you have to change two different size screwdrivers just to get the job done. Should be free now. Possibly a keyboard backlight there. Ah. Okay, well, nothing looks charcoal on this side. Anything obvious over this side? Not really. Oh, good. Alright, let's see if we can trace this all through then. Nothing looks bent or horrible. This might be one for the thermal camera. Trying to figure out where the short is. Where's our input MOSFETs on this? How are they doing that? Normally they're a bigger device. Here we are. That'll be these little ones here. These little ones here. Let's just see what side of the MOSFETs that short's on. There we go. That side there. Alright, I'm just going to probe 1 volt into the end of that capacitor here, and we'll see what gets warm, if anything. Drawing only 260 milliamps. It's not enough. Let's revisit our measurement there. So, having a closer look at the input, so that where I thought I measured a short here, if I take that measurement, I'm getting 2 ohms. 2 ohms could be, maybe it's okay for that rail. I don't know if that is on our input as yet, but what I am getting here, here's our MOSFETs, our input MOSFETs. So what I am getting here is a 1 ohm short, nothing on that side, nothing on this side. Now our positive in, I get a reading here and here, which is very strange. It shouldn't be shorted through the MOSFET. Let's just check the MOSFET there. Okay, that MOSFET appears to be shorted. So it's shorted to the gate as well. So this MOSFET is a total short. Oh, right, that's just lovely. This MOSFET's okay. I've got 0.5 volt drain source there. If I go the other way, I've got nothing. If I go gate, I've got nothing. Okay. How about we take that off and see if that solves our problem. Unplugged our input, DC input lead there, just so we don't melt it. Okay, now we will check, is it still shorted? It's probably dead hot. But yes, it is shorted. Let's put another MOSFET on there and see what happens. EA011P. Let's go see what that is. EA011P is not the number for it. Okay, what's the other number then? 21321. 21321. That's better. Ah, crap, it is a P channel. Ha! Lucky we checked. Let me check my stock list. Man, every board I've looked at, every spare parts board I've looked at, they're all N channel. Seriously, like what kind of delinquent makes stuff with P channel MOSFETs? S412, that's an N. I might have to go to a MacBook board. Oh, what do we got there? 7716. Oh, I haven't seen that number yet. What is a 7716? N. Everything uses N. Okay, let's have a look at an old crusty old MacBook. Oh dear. Bit harder to stand out with the old silk screen and brown. 7615. 7615. P. Yes. Looks like we have our winner. 7615. P channel, 20 volt rated, 35 amps. Okay, cool. So that's beside that pogo pin. Good. The old one, that is 30 volt and 24 amps. Okay, we're on a win. Wouldn't worry about it's not going to, well, maybe it should be good to overrate it. It's going to be right on the limit of the charger at 19 volts. Make sure the charger is 19 volts. So it's not ideal, but it's all I've got. And I will make a note to order some more 19.5 volts. I have to make a note to order some of those high powered P channel garbage. Right, where is it? I'll take it off the board. Right, where's pin 1? Here's pin 1. Let's make sure that our gate is pin 4. Looks like it. Perfect. Wonder what temperature alcohol spontaneously ignites. I have yet to see it happen by applying it to a freshly heated board at 360 odd Celsius. Maybe we should run an experiment. We'll crank it up to 500 and whatever that station goes up to, and get the board stinking hot, and then pour alcohol on it. Well, maybe not pour it on, that could end badly, but a freshly doused cotton swab probably do the job. Being on our input, we can go to 19 volts. I'm just going to start out at 1, just over 1. Let's see if anything lights up on this side of the board. 2 amps. Okay, something's got to be warming up. There it is. Whew. That got really warm. But I think it was on the other side. Just do that again. Yeah, that's coming through from the other side. Alright, let's flip it over. Okay, I might have to stick a wire on because I don't know what to probe on this side. Let's do this again. 0.6 amps. Maybe my probe touched something it shouldn't. Possibly something getting warm there. Take the power off. Yep, it's cooling down. Okay, we have got something going on there. A little bit off as far as there's a little bit of parallax error in the lens, so the hot spot's not exactly on top of where it should be, but okay, it's below there. Oh, well, it's just a current sense resistor or a capacitor. I need a macro lens. Let's put some alcohol down there and see what's boiling off. Right, hopefully you can see this. But if you look at, see the green current sense resistor, the capacitor that's directly below that, hopefully you'll see some bubbling coming out of it. Hey, look at that. There's our short. It's burning off all the alcohol. All the alcohol. Let me add some more alcohol. I'm just holding a torch because I'm too poor to have dual voltage source, so I can't have my ring light and use the power supply at the same time. Okay, here we go. One more time. Bubble, bubble, bubble. Right, let's remove that little capacitor, shall we? So with better lighting, there is our exact suspect. I won't say it is actually the one, but let's just do a resistance measurement on there and just make sure we're not dreaming. Yep, okay. Shorted both sides. Let's get a little bit of the flux, and now this is on the input, so it's going to be a 20 or greater. It'll be greater than 20 volt rated cap, probably 30. One thing I've noticed is if you get your tweezers on it while you're heating it, your tweezers get hot. It kind of acts like hot tweezers. There's a solder iron tip. It does help get that solder melted to have that extra bit of heat applied indirectly. Yep. Dead nuts short. And just to make sure we don't have another short still on the board, we don't. Look at that. Alright, let me find what I've got as far as replacement caps. So I have 10 mic and 25 volt. They're the same size even? Hey, close enough. I tend to hold the replacement parts out of the airflow until the solder gets liquid and then bring it in, so we're not exposing the part to too much heat. Interesting. When the alcohol evaporated, we've got this funny white stuff. What's that going on there? Has this had a liquid damage in here? That's maybe caused that cap to go off. See, there's some white stuff appeared over here. I might just give that a bit of a scrub. Heavy duty paper towels are amazing things. Great way to soak up all the excess flux and such. One last check, make sure that we're all good and we have no short. Alrighty, ground to input, no. Problem solved, one cap shorted. The surge current destroyed this input MOSFET. Now we're all even. Let's get it back together and see if it charges and turns on. So the end is a bit rushed. The owner came to pick it up. As you can see, it's working and everything's good. It's charging, it's happy. So thanks for watching and we'll catch you in the next one.